Hey Kenny, do you remember Hurricane Katrina?
Yeah, so that was a Category 5 hurricane that occurred in 2005, and it impacted a large portion of the United States. In fact, it's the worst hurricane storm in recent history for the United States. It was a Category 5. It occurred near the Gulf Coast, and it was a very, very large natural disaster.
Yeah, so it ultimately impacted the New Orleans and Louisiana area, but the impacts were widespread over the Gulf, and it affected a large number of people. So in this exercise, we're going to track the path of this hurricane and look at sort of the rate at which hurricanes travel and put that in the context of some other storms that we've talked about, and then calculate the warning or evacuation time that people had for this hurricane.
Okay, so we've plotted points here, and each point represents the center of the hurricane at a specific moment in time. And so you can also see this on your activity at the table. It lists the latitude and longitude coordinates of this particular point set.
Okay, so yeah, we have the latitude here and the longitude across the bottom. And so we transpose these points onto the map and we colored them based on the wind speeds. Now the Saffir-Simpson scale goes from a tropical depression all the way up to Category 5 hurricane wind speeds. We only have 4 colors, and in our case, these pink points, they represent the higher wind speeds, and these yellow points represent the lower wind speeds.
Okay, so and if we connect the dots here, we can trace out a track for the hurricane.
Okay, and I'm going to keep the track representing the wind speed, so I'm going to try to color the track appropriately. Okay, so now that we have our track, we can see the path that Hurricane Katrina took through the Gulf.
Okay, and so if we know how fast the hurricane was traveling and the distance that it's moving, we know that we're probably going to need our friend the rate equation in this problem.
Right, it does sound like the rate equation will be helpful to then calculate sort of warning times and evacuation times for cities along this path.
Okay, so I'll go ahead and write it up over here.
Okay, and so our first problem is we're going to look at this portion of the path where Hurricane Katrina made its first landfall on the southern tip of Florida. And so we're in particular going to look at a point starting on August 25th at noon, which is this point here, sort of off of Fort Lauderdale. And we're going to calculate how much time the residents of Miami had to evacuate from the storm.
Okay. So the first thing we probably want to do is measure the distance.
Yeah, so you would get your ruler and you would measure the distance between these 2 points, the one that's offshore and then the one that directly covers the city of Miami.
Okay.
And so with my ruler, I measured this to be about 0.6 centimeters on the map.
Okay, so I'll go ahead and rearrange this equation so that we have time on one side and everything else on the other. And so we have time is going to be distance over rate. Okay, so you said that you measured the distance to be about
0.6 centimeters on the map.
Okay.
So this means that we need to change this into distance in the real world.
Right, so when we write this out, we have to be aware that we're going to be changing units here.
Okay.
So we have our distance was 0.6 centimeters on the map.
Now, if I hold my ruler up to this graphical scale, I measured that about 3.1 centimeters on the map is the same as 500 miles in the real world.
Okay, so, and the way this is written, we need to put the rate underneath as well, and we know that it's traveling about 6 miles per hour.
Right, so that's given to us in the problem.
And so, and we need to multiply this by, because you were saying that 500 miles in the real world is equal to 3.1 centimeters on the map.
Right, so we need to do our distance conversion between map scale and real world scale.
So 500 miles is?
The same as 3.1 centimeters on the map.
3.1 centimeters on the map, okay.
Yeah, and I chose, you'll notice the graphical scale is both in miles and kilometers. And I chose to look at the miles portion because our rate is in miles per hour.
Okay. So we know that the centimeters are going to be canceling out here.
Right?
And if we multiply out our numbers and our units, we come up with...
This is about 16.13 hours. Okay, so it took the storm about 16 hours to cross from this offshore point here to make landfall at Miami.
Okay.
So those residents had quite a bit of time to prepare. Okay, so now we're going to look a little bit farther along the storm path in the Gulf and the second time that it made landfall over New Orleans.
Okay. So if we wanted to look at this area here, we want to know what the approximate time that the hurricane is there. And so if we're examining a couple of points here, let's say this point here, then it's there at about 12 a.m.
Okay.
And then this other point, this green point up here, it's there at about 12 p.m.
So it makes landfall at that point. And so we want to know the distance that it covered in this period of time.
Okay. So I measure this distance on the map to be about 1 centimeter.
Okay, so the distance is 1 centimeter on the map.
So, and we know from the scale that 500 miles is equal to 3.1 centimeters.
So 500 miles in the real world is 3.1 centimeters on the map.
Okay.
Now, this is in the numerator and the denominator, so we can cancel. And so we have 1 times 500 divided by 3.1, which comes to?
We get 161.29 miles.
Okay, so this distance here is about 161 miles.
Okay, and so since we know that the hurricane was here at 12 a.m. and here at 12 p.m., it was 12 hours difference between the 2 points.
Oh, okay, so we can just plug that into our rate equation.
Right, so now we know the distance and the time. So if we use our rate equation here, the distance was?
161.29 miles. And the time was 12 hours between these 2 points.
Okay.
Okay, and so that comes out to be 13.4 miles per hour. So we can see that these storms travel maybe a little bit slower than some other severe weather events that we've talked about, like tornadoes, for example. And so that gives you typically ample time to evacuate.